Okay, welcome to Chapter 3. Chapter 3 is on the relational model and normalization. I kind of hinted at the fact that normalization is a really important concept and something that you're going to have to learn. Unfortunately, a lot of the textbooks and even supplemental material that you might find on the internet do a very poor job of describing this. So you're really going to have to pay attention to the videos to be able to understand this. Okay, page 152, they start talking about the learning objectives for this chapter. So what is the relational terminology, right? That's simple. Identify functional dependencies. We'll define what that is in just a minute. Identify primary, candidate, and compound keys. And then identify modification anomalies. Now that's a phrase that we're going to be using a lot, so just kind of pay attention to those things. So let's just start from the beginning. You might think, well, building a database is kind of simple. You just slap a bunch of tables together and go on about your business. But it is not as trivial as you might think. For example, here is one where I have a choice between having an order item table and a SKU data table. Or I can have it all stored in one table. I really have a choice between how to do that. Here, I have an order number, so order number 1000. And they bought two items. Whatever this item is, they bought one of them. And whatever that item is, they bought one of them. And over here, here's just like their inventory. This is all the things that they sell. So there's no duplicates in here, okay? And I can kind of sort of see that the primary key on this table is these two columns together. And so there's no duplicate. If you consider two columns, there's no duplicates in this. And there's no duplicate data in here. But here, there could be lots and lots of duplicate data. They could have SKU numbers that are the same. They could have order, all sorts of other things. So this is, having it all together means there's an awful lot of duplicates. And you might think, well, what's wrong with having a bunch of duplicates? What's the big deal? All right, let me tell you a story. So my girlfriend moves in with me, and she had a bunch of magazine subscriptions. So she called him on the phone or sent him a note saying, I've changed my address. And we started getting two magazines, one at her old address and one at her new address. And then later we got married and she changed her last name. So she sent him a note saying, okay, my name is changed. And then we started getting three copies. The old name at the old address, the old name at the new address, and the new name at the new address. So what's going on here? Well, the reason is they had the data in too many places. They had too many duplicates. So when they signed up for making changes to the name or changing to the address, it was probably in 3 or 4 locations in their database, and they only changed it in one location. They changed it in the billing department, but didn't change it in the distribution department where they actually get shipped off. So having data in 2 different places is not a good idea. It's always best to have it reduced down so that the data on orders is only in one place. The data on the inventory is only on one place. And the data on, that's just the way it's done, okay? Now, we're going to go through some terms here to talk about that. The first term they talk about on page 154 is a term called a relation. So a relation is basically just a fancy word that says a well-built table. Okay, that's all a relation is. Don't get too hung up on the terms here. So let's talk about some of the other terms they use. So a relation is just a well-built table. Functional dependency, we'll come back to that. A functional dependency is a way of saying, if I give you a student ID, given a student ID, I should be able to tell what the student's first name is and last name and what their major is. It's how things are related together. You give me one part and I'll be able to tell you the rest. A determinant, that's the other part. That's the thing that makes the functional dependency work. Like given a determinant of student ID 1, 2, 3, 4, I can tell this and this and this. A candidate key. Now we talked about a primary key. Primary key is the one that uniquely identifies a row. Okay. It could be a compound or composite. It could be, for example, in this case, a single column can't uniquely identify this because you can tell there's duplicates. So I have to combine these two things together to make a compound, or they say composite, a compound primary key. Okay, a candidate key is a key that could have been used as a primary key, but you just chose not to. Let me give you an example. So at the university, you probably have a university ID and you probably have a university email address. Both of those are unique, not shared with anyone else, and both of those could be used as a primary key on the student table. But we don't need them both. So we picked the student ID to be the primary, and the other one just becomes a candidate. It's not really any, it's not a lesser key. It's just, we just chose not to use it. Okay. A surrogate key, this goes by lots of different terms. A surrogate, an auto number, a synthetic. These are keys where I've looked at the data and I can't see anything in here that would make any sense to make a primary key. I'm just going to start numbering these things. So whatever the first one is 1, whatever the second one is 2. And just have the machine automatically number the rows for me because there's no key in here that I can find. So if you look at it and go, oh, screw this, I ain't going to find a key, then use an auto number. A foreign key. Foreign key is the one that connects the tables together. It's a column in one table that points to a column in another table. And I mentioned before that they don't have to be the same, exact same words and exact same columns, but it would certainly make life an awful lot easier if you did it that way. Referential integrity means that when I've had it configured with this foreign key, I can tell it so that when it comes time to enter a student ID and I pick a major, if the major is not on the list of acceptable majors, like I misspell it, I was going to type in, criminal justice, but I misspelled it. Well, then the machine will come up and say, I'm sorry, I can't do this insert because referential integrity says that field must match something in another table. That's what that's about. And referential integrity is great because it prevents you from putting garbage in your data, which is one of the rules that's very important. Normal forms. We're going to spin an op. These are the rules that you use for doing normalization. There's a normal form 1, 2, 3, that kind of stuff. So we'll get to that. And a multi-valued dependency. That one is a little bit more complicated. And it's a special type of normalization issue that we're going to have to describe. Okay, so we're going to get to all these again, so don't panic. The first one, of course, is the relation. So let's talk about what are the rules for a relation. All right, there's a bunch of rules. So one is the row should contain information about a single entity. So for just a hypothetical, if you had this in Microsoft Excel, you could have like half of the row be the first student and the second half would be the second student. And you could have 3 and then 4 and then 5 then 6, right? You could do that in Microsoft Excel, not in databases. A single row represents a single item, okay? You can't split the row, okay? So this one is kind of sort of easy. What this basically means is that if I'm talking about students, then everything in that table has to relate to a student. I can't have things like, grade, I don't know, what classes they're attending. No, that's something else. A student is just about students. Okay. Rows or columns contain attributes. Okay, that's kind of goofy, but what that basically means is that each row contains the first name and last name. Those are attributes. Okay. All values in a column are of the same data type. I can't have a column where it starts out being numbers and then you switch over to words and then switch back to numbers. All the data types have to be exactly lined up. Okay, each column has to have a unique name. All right, so I can't have first name and then another column called first name. Okay, each column has to be unique. And each cell, meaning the intersection of a row and a column, should contain just one thing. So for example, if you were trying to put in phone numbers, and they were expecting you to put in one phone number, they don't want you to put in 2 phone numbers in that little cell, okay? They one item. Okay. And here's some rules that are kind of weird. It's an anti-rule. Basically what it means is the rows, the order of the columns is not important. If you switch things around in the column, nothing changes. And if you change the rows, nothing changes because The machine is not guaranteed to always put the columns in the same order or the rows in the same order. Okay, and then no two rows can be identical. All right, there's a couple of things that are kind of missing from this set of rules. All right, one of them is something kind of simple, and that is the all rows should have the same number of columns. That kind of makes sense. You can't have like 10 columns in most of them, but a few of them have 11 columns. You know, that kind of makes sense. And now they don't mention anything at all about null values. You know, where you could leave things blank, because that's not part of these rules. Okay. So what I'm going to do is I'm going to bring up an example here in Chapter 3. Okay, so here's an example of how to violate the relations rule. All right, here we go. So I have a student ID, a first name, last name, whatever their primary major is, some student type. I don't even know what that is. I guess maybe it's like, you know, what year you're in, and then phone number. Okay, so far so good. I don't have any problems here, but wait. I've violated the rule here because there's multiple items in a single cell. Okay, that was one of the rules, remember? That you can't have, at the intersection of a row and column, you can only put one thing in. Here, it looks like I was expecting numbers, and then I switch over to text, then I switch back to numbers. That don't work. In here, we tried to solve the problem of having two phone numbers by just putting the second phone number underneath it. But remember the rule about the order of the rows don't matter? And therefore, there is no guarantee that row number 9 is always going to be next to row number 8. So that's not going to work. And then over here, I have an extra column. Everyone else just goes out the phone, but over here I have an extra one out there. So that doesn't work. And then here, wait a minute now, it looks like I have a duplicate. Let's see, 1, 2, 3, John Doe, math, 3, yep, I have a duplicate. So line 3 and line 10 here, both are the same. Okay, so I violated practically every single one of the rules that they have here. Okay, that making sense? Good. Okay. Now, let's go back to some alternate terminology, because the database people, can I go ahead and say this? Database people are crazy, all right? Here's some terms. Some people, what I usually say table, but you could also say relation, or you could say file. Those three things all mean the same thing. A column, an attribute, or a field, those are all the same. A row, a tuple, or a record, those are all the same. Don't get excited. I'm typically going to say data, column, and row, because those are the things that most people intuitively understand. What the heck is a tuple? That's just dumb. Okay. So yes, a tuple is, you know, a row. Okay. All right. So on page 158, they start talking about the keys. Remember the keys? So a practical application of the last rule of a relation is to have a primary key. That's just a practical way of thinking about it. So the primary key, and by the way, I'm almost always abbreviate this when I'm sending you like grading notes and stuff. I'll abbreviate it PK. PK for primary key, FK for that kind of stuff. Okay. So let's go back to our example here. So what would be the primary key here? Well, it looks like I could just get away with, you know, the student ID. But no, because I got 1, 2, 3, 4 of those guys, so that's not going to work. So what's the primary key? It's like, well, it can't be that, and it can't be that, and it can't be that. It's like, geez, I don't know. I mean, this would be one of those situations where you scratch your head and go, I think maybe I need a compound primary key, because I can't figure out how to make any of this come out right. So let me give you a better example that uses a compound primary key. So here's an example of a course schedule. It talks about the semester, the course ID, and the professor, and then the section, a class type, room number, days, and start time. I tell you what, before we get into this is probably a good place to stop for the 15-minute mark.